Hey, folks. Welcome
Hey there.
to another Quarkus Insights with Gunnar today, talking about Kafka Streams. So, as you see, it's
Right.
just me and Gunnar today. Max, Manuel, and Jason, the regulars of this show, have various other things they need to attend to. So, we'll
Traitors.
have, yeah. But anyway, we'll have an interesting one-on-one chat because Kafka Streams is a really hot topic. I know a lot of people have been asking about it. Has high demand, and we have various questions on our our Quarkus Dev lists and stuff.
Mhm.
So that should be good. It should be great. Gunnar, you want to start out by talking about yourself a little for the folks that maybe don't remember from what was it, like 3 or 4 weeks ago you were
Yeah,
here
right.
on?
Sure. Absolutely. Yeah. So thank you so much for having me again. I cannot believe it.
Thanks for coming.
Yeah, absolutely.
Always a
So
pleasure.
yeah, it's so great to be here. So I am Gunnar. I work as a software engineer here at Red Hat, and well, usually the project I'm spending my time with is called Debezium, and this is a tool for change data capture. So this means it hooks into your transaction log of your database and extracts change events out of it and sends them to Apache Kafka. There's a few other things I do on the side, and one of them is this Kafka Streams extension for Quarkus, and this is what I'm going to talk about today.
Excellent. But since we're in the Hacktoberfest month, you've done a lot of other open source stuff as well, right? So you want to give a quick history about
Oh, yeah, sure. I mean, yeah, so I've been doing a few things at Red Hat. So before Debezium and now this Quarkus stuff, I've been contributing to Hibernate quite a bit. So I've been involved with bean validation, which is a spec for putting constraints to your Java object model and validating those constraints. So I've been working on that. I've been working on its reference implementation. I've been doing a few things around Hibernate RM here and there. I've created MapStruct, which maybe some of you know, which is a compile time code generator for bean-to-bean mapping code, which actually works very nice with Quarkus because it doesn't use
that was
any
gonna be my next
reflection.
question. Exactly.
Right. Yeah, there's and a few other things. There's Larry, which is a tool for building modularized layered Java apps. Maybe I can talk about that another time. So yeah, quite a few open source things.
Cool. And for folks that haven't seen it, Gunnar usually does a lot of experimentation with really avant-garde JDK stuff. So we've seen a lot of cool experiments. Hopefully we'll see your, what is it, the JMX to JFR thing that you...
All right. Yeah, absolutely.
You know?
Yeah, exactly. So JMFRX.
That's a mouthful.
Yeah, absolutely. I mean, and that's a bridge essentially for getting your JMX events into JFR recording. So there's the JDK flight recorder, which is this super awesome low overhead recording engine for recording all kinds of metrics really about your CPU usage and JDK specific events like file system events and all those kind of things, network I/O. And well, sometimes you still have JMX metrics in your application. And actually, Kafka Streams is a good example for that. And this is a little project which helps with essentially capturing those JMX metrics and recording them into a JFR recording. So you can analyze them offline. You can take a look later on and so on. So yeah, I hope to push this to the container JFR project, which is an effort for making the flight recorder very well work with containerized Java applications.
Excellent.
Yeah.
All right. So how about we get started with the topic in hand today, which is Kafka Streams.
Yeah, sure. And please, people, if you have any questions or specific things you would like us to talk about, definitely put them into the chat. I'm not sure I think you can do it on YouTube and here on Restream. So wherever you can, put your questions, and then we will try to get to them, right? And
Absolutely.
the idea for this one is to, explain a little bit where this Kafka Streams extension is coming from and, why you would like to use this, and maybe also touch a little bit on why you would want to use Kafka Streams. And then, I would like to make it a bit more practical, so show you some of those things in action. There's support for this awesome Quarkus Dev mode, things like that. So it should be a bit hands-on. And again, if you would like to know certain things in more depth, or you want me to touch on specific details, just put a comment into the chat and we can, or I will try to answer them as good as I can. All right. Yeah. So Kafka Streams. What is it? What is it? It's an API for stream processing. So essentially, it allows you to run streaming queries on your Kafka topics. So this means, well, as opposed to a database where you write your data, and then if you would like to get some answer out of it, you need to go there and you need to essentially pull data from the database. You need to run the select, and this is like an ad hoc measure you need to do. Whereas with Kafka Streams and stream processing APIs like that, it's the other way around. So essentially, whenever there's new data arriving on such a Kafka topic, this stream processing pipeline will be re-triggered, and it will re-evaluate this logic, and it will give you this answer right away. And it allows you essentially to do things like, let's say I have an e-commerce application, and I'm interested in what's the aggregated revenue per category of my products in a time window kind of basis. So what's the revenue of the furniture category in the last hour in a sliding time window basis?
Sounds like something a CFO would like to know.
Exactly right. Yeah, and you get this, let's say, in a low latency, near real-time fashion, right? So you don't need to go to the database and ask for it, but you will get the data in a push-based fashion. So that's the huge difference. And now there's different APIs like that. I like Kafka Streams for several reasons. Well, it integrates very nicely with Kafka. It exposes all the Kafka semantics, and it supports, takes advantage of all the nice features in Kafka. But also it has a very nice deployment model. So it's a Java library, which means you don't need to operate a separate cluster or anything to run the stream processing application. Instead, you embed it into your Java library, and then you can run it as any kind of other library you would be using. And this also means, of course, you need to take care of a few things, like starting up this thing, configuring it. You need to make sure you shut down when everything is done. You shut down properly. You are sure you've seen all the input topics. And maybe there's other things like you would like to have metrics or health checks and all those kinds of things. And this is where this Quarkus extension for Kafka Streams comes into the picture. It essentially provides a runtime, let's say, an environment for building Kafka Streams applications on the JVM and also on GraalVM. So that's another interesting aspect of it. You might want to run your Kafka Streams apps as native binaries on GraalVM, and then this Kafka Streams extension provided by Quarkus will also take care of making sure that you can actually do this. It takes care of the reflection configuration and all those kinds of things.
So just to be clear, like for people that are just starting with Kafka Streams, so you can like write your own Kafka Streams. Like you said, it's just a library that you embed in an application, so you don't need to use a framework.
Exactly right. Exactly right. And maybe actually I can show this to you. So here, so do folks see my screen? Yeah, right, there you go. So that's essentially, I took a look earlier today on the Kafka website. So that's essentially like the basic, let's say, boilerplate you're doing if you want to run a Kafka Streams app. So you have your own main method. You need to do some sort of properties to configure the thing. Where is my Kafka server? Things like an application ID, all those kinds of things. And of course, this already raises the question, right? So where do those values come from, and how can I override them? So that's something you need to take care of. Well, then you do different things like creating this topology, and that's actually what we are after. So this describes what is our logic there. And then you have to do a few more things like adding this shutdown hook, so to make sure it's started and stopped properly. There's this latch involved. So I would say it's a bit of boilerplate, right? And really the only thing which actually is meaningful here, or really meaningful, is this one here. So this topology, this is what I really need to implement. So this describes what kinds of joins do I do, like aggregations and groupings and so on. And so the idea of this Quarkus extension is to essentially take care of everything else. For instance, properties, you can configure them using the application properties file. And really then all you need to do is you need to focus on implementing this topology, because this is really where this logic is, right? And then it takes care of starting everything, takes care of awaiting that all the input topics exist. It's another thing to take care of. So if a topic doesn't exist, this wouldn't even start up. So this is what it's doing, and so on. Right.
Excellent. Excellent. Yeah. Okay. That's cool. So yeah, this is like a lot of boilerplate, and it's stuff that's like intermingled with the infrastructure and the actual, let's say, business logic you would want to implement is all in here. So yeah, this does not look. This looks like something like a student would write.
Yeah, and you don't want necessarily to take care of that, right?
Yeah,
and,
exactly.
That's the idea of having this extension. So let me go to my IDE and well, now this is actually how this looks now. So here I have a application scoped bean. So that's an application scope CDI bean. And this one has a producer method, and this is really the only thing I need to do essentially. I need to have this producer method which returns my topology. And sure, now this is my actually logic I need to implement. And if you look closely here, nothing much happens yet. So essentially, I just take a stream from one topic and I write it out, to another topic. So that's what's happening here. Maybe to explain a little bit on the domain of this example. So it's about weather stations and temperature measurements. So I've got two topics, one with my weather station, let's say master data, like coordinates and the name and so on. And then I have another topic with temperature measurements that's like fake IoT data about, measurements from those different stations. And the idea is to join those two topics. So I also, for each measurement, I get the name of the weather station where this is from. And then to do some more things like aggregating the value and calculating the average measurement, for instance, per weather station. So that's the idea for now. All I'm doing is I'm just take the data from this stream and I write it out to another topic. So in Kafka Streams, essentially, I have those two major things. I have something like a stream. So this really essentially is a stream of data which is based on a topic. And I have another construct which is a K table, or in this case, a global K table, which essentially gives me the current state of a topic. And I can use this here to enrich the stream with this master data coming from this global K table. All right, so that's my streaming topology. And then in terms of the configuration, I'm using the standard Quarkus configuration mechanisms there, my application properties file. And then here I have things like, these bootstrap servers. So this is something I can override. And now, as I use the microprofile config API for doing that, I can override this using environment variables or system properties, or maybe even a secret or config map. And if I were to run this on Kubernetes, and for my application, this all is fully transparent.
Yeah, so that's a point that I wanted to touch on. Basically, this the extension that you have, the Kafka Streams extension, is like a first-class citizen for Quarkus, which means that it can interact with all the other great things that Quarkus has. So like the dev mode, the native image, you get configuration out of the box, you get all these cool things basically for free, right?
Exactly right. And exactly. So there's configuration, there's dev mode, we will see that. There's some health checks built in, so and all those kind of things. And to show this a little bit, so I'm starting this one up, and so I have Docker Compose running here. And let's take a look into the compose file. Where am I? Let's see. Oh, so here I don't have too much in it. So I just start essentially a single node of Zookeeper, which is some management infrastructure I need for Kafka. And then I have another single node of Kafka itself. So I just start those two things. And I'm going to start my Quarkus application in dev mode running on my host machine here. So let me just take a look. This is, for some reason, it's taking super long to start up. I'm a bit afraid this is because the video video recording stuff takes lots of CPU. So I'm hoping this is coming up. Let's give it a second. Maybe, what can I show you in between? Yeah, maybe let's go. Yeah?
Yeah, go ahead.
Let me go to my stream processing application there, and let me already expand this a bit so I can use the time. So what I'm going to do is, I'm not typing this also, I'm just pasting this in to save a little bit of time. So what I'm going to do is I'm going to join those two things. So here now I say I would like to take this stream from the temperature values topic, and I'm going to join this with this stations K table. This means essentially whenever there's a new element on the stream, it should be enriched with this data from the other side of this join. And what I'm doing there is essentially I'm just taking my temperature measurements, which are like a semicolon separated value, and then I propagate the station ID and the station name, which comes from the other side, into the result. Let me fix the imports. And by the way, the join, this is done on the key of those Kafka messages. So Kafka messages have a key and a value. And in this case, I have the weather station ID on both sides as the message key. And this is why I can do this join there. All right, now, and I also need to fix the 30 here. So the 30 is essentially a means of serializing this data into Kafka. So for here, I need to take the temperature measurement 30. All right, so let's save that. So let's see what my thing is doing. Okay, so it seems there. So then let me take a look into so and I need to have some data, right? So and that's why I have a little producer application, and this is another Quarkus application which just creates random temperature measurements, right? And it writes them to this Kafka topic there.
But that doesn't need to be Kafka Streams application, right? It's just a Quarkus application that writes to Kafka, nothing else.
Exactly right. So that's not using Kafka Streams. That is just using this reactive messaging API and put some data into my Kafka topic. And this is sort of just a means, to have some data for me. As I see here now, okay, it's producing those random values.
So you're simulating like various temperature
sensors. Exactly right. So I don't have my own network of temperature sensors around the world. So that's what I'm going to do. So the next thing is I'm going to start up here. I'm starting my stream processing application in the dev mode. So that's what I'm after. And essentially the workflow is to start the stream processing application in the dev mode, have some data which is coming in, so that's produced by my data source there, and then to take a look into the output topic and see how this reacts to my implementation. And for that, I'm going to use this tool, which is called Kafka Cat, and it's an awesome tool for interacting with Kafka topics. So that's what I'm opening up here.
Okay, so it's the UI for Kafka.
Let's say it's a CLI client for Kafka, right? And so now this is actually working, right? On my original topic, I just would have those separate values, and here I already have the output containing station name and so on. So this join actually is working. Actually, let me just stop this and let me pipe it to JQ, so to have some nicer highlighting there. Now the idea is I can keep going now and work on this application logic. So let me go back to Eclipse and let me make this a bit smaller. I feel like my machine must be like exploding every minute. I hope it will survive. So let's see. Closing that one. And now actually what I'm doing is I'm adding another step to my application logic there. So I'm putting in this kind of grouping and aggregation. So now essentially for each weather station, I would like to aggregate the data. So I group it by the weather station ID, and then for each station ID, I run it through this aggregation operator. And I will take a look into that one. I just need to update the 30 again. So that would be now the aggregation 30.
And Serde is a serializer, deserializer, right?
Exactly right. Exactly right. And I'm just not sure what is missing. Oh, yeah, no. This string missing. There you go. Exactly. So, and now the thing is, I hit save, and it will automatically pick up this change. So, as you know, the dev mode from the web applications, it's exactly the same for the stream processing application. So now if you look closely up until, a bit here, I have just those shorter messages. And now this aggregation is also kicking in. And, I instantly get a feedback for how does this application look like now there. Now I can't...
I think it passes the eye test because you have emojis in there, so it must be great.
Right, exactly. And actually, I meant to keep those emojis for another step. But anyway, so let me just, I'm going to copy it so you see, you get a little bit of the feeling there. So usually I would do something more meaningful, right? But so let's say I add another attribute, icon2, and again, I'm going to save. Quarkus detects this change, and it reloads the entire thing. And then here I see now, okay, I have also this icon 2, right? And this allows me essentially to, well, iteratively work on this stream processing application. And, I don't need to restart it all the time. I just keep going. I work on the stream processing pipeline. I see how it behaves by examining the output topic there. And I feel it's a pretty nice and productive way to work on this kind of application.
That's a great workflow. I mean, yeah, you don't need to restart or anything.
Exactly.
Yeah, that's cool. So basically here you're writing your own aggregation, right?
Exactly right. So, and I mean, that's the thing you need to be aware of Kafka Streams, right? So it's a Java application, a Java API. So you need to think about it in terms of Java programming and how do I aggregate data and so on. You need to be a Java developer in order to use this, but then also it gives you all the flexibility. Let's say you wanted to do, some external service invocation, like going to some web service and get the icons. I don't know, maybe I have an icon web service. I need to get my icons from there, right? So then it's something I just can easily do in this Java-based stream processing pipeline because I have all the flexibility of a Java library. So that's the thing. So let me do another thing. So let me stop the output there.
Let me, before you go to that, we have one question. It's not really related to Kafka Streams, but it looks like it's in Spanish. I don't know a lot of Spanish, but
oh wow,
I'm guessing that it says, can we run Quarkus applications or like this Kafka Stream type of messaging application on Azure functions? So the answer is yes, right? We do have integration with Azure functions,
right?
Now I'm not like familiar with Azure if it has any like Kafka service or something like that.
Yeah, I mean there's a Kafka service on Azure which you could use with Kafka Streams, but as far as I know, Azure Functions, that's like a function as a service API, right? Like Lambda and so on. So that's kind of a different thing, really. You wouldn't use Kafka Streams with that, but you could, of course, use Quarkus to build Azure Functions applications using the funky stuff and everything.
Absolutely.
Right. So let's see, and I want to take a look there. Let's say now I would like to add something like a health check. So I would like to see, do I have, do my input topics exist and so on. So, and for that, I'm going to add an extension. Now I'm trying with my luck. Let's see, add extension, and it should be maybe just health.
I think it's Quarkus. Oh yeah, you can add.
Let's try that, and I need to be maximize. So let's see how that works. And this should now add this Quarkus health check extension. I hope. Not sure what it's doing. And the interesting thing there is this would expose some endpoint for me, which shows me do my input topics exist. So let's give this one a try. And usually, as I mentioned, it's a bit faster. I'm not quite sure what's taking so long, but blame it to my machine. I need to talk to my manager, I believe. get
a new machine. Like, this is the opportunity.
Exactly right. So let's see. But actually, it could also be something is actually wrong also with my stream processing. Let's give it a second. Let's see what's going on.
Okay, so how about let's take a little step back here. What are folks' alternatives to, let's say, Kafka Streams? Okay, I mean, we hear a lot about like Apache Spark or Apache Beam and stuff like that. How does Kafka Streams compare to that sort of thing?
Yeah, so that's a great question. I must admit I'm not the biggest expert on all those kinds of libraries. I would say the one big difference definitely is in the deployment model. So as I mentioned, so you don't need to stand up a dedicated cluster kind of thing to run this. So this is just part of your Java application. I guess because, well, it's a part of the Kafka project, it gives you really like all the latest Kafka features that allows you to take advantage of those. But definitely something like Flink also is great. And for instance, they have bespoke support for Debezium change data capture now. And well, this is interesting because it allows you to integrate with different messaging infrastructures, right? So with Flink, you could work on Kafka topics. You could work on, I don't know, all kinds of data sources, Kinesis, and so on. So there's a portability story at play, right? Okay. Right, but so I think all those APIs have their advantages, disadvantages, and you should choose what matches your specific requirements best, I would say.
Yeah, but to comment on your first point, yeah, on my previous job, I did run Apache Spark, and yeah, having to manage the cluster was not fun. I mean,
oh yeah,
yeah, that's definitely something that you would not want to do. So yeah, I see this model like just a plain old Java application running for your streaming processing. I think that's really great because you can automatically, like what you said earlier, right? Let's say I wanted to pull something out of an external service to join the data. With Spark, it was like really hard to do that because you couldn't use any libraries or frameworks or stuff like that. You have to manually write all this code just to do something that trivial. But with this, if it's a Quarkus application, you can just use the REST client or something and just bring the data in with like one line of code or something.
Exactly right. Exactly. So let's give this a try. So I don't know, it took for ages to start up. Let's try just to see how this health check looks like. It's a bit embarrassing, but there you go. So again, under the standard health endpoint, it exposes now those health checks for my Kafka Streams state, and I see okay, it's running. I see all my topics. So in this case, I'm working on the weather stations topic and the temperature values topic. So they exist, and this all is functional. But let's say one of the topics would not be present yet, then we would see in the health check here, okay, this input topic doesn't exist yet. And, the application would signal that, okay, I'm not ready yet. And then, well, if you were to run this on Kubernetes or some kind of orchestrator like that, you would see, okay, something is quite ready yet. Maybe I need to create this topic. Maybe it's something I need to set up manually, those kind of things. So this lends itself very nicely to running in a cloud-native environment where you would have those kinds of things.
Yeah, that's great. The application itself is signaling like what the dependencies are.
Exactly right.
Yeah, that's great.
Exactly right. So let's see. What else? So how much time do we actually have?
We have about half an hour. So.
All right. Yeah, maybe I'm just going to show one thing in code because I feel if it takes so long to start up, I probably will run a bit out of time. But what I want to show is I also can do quite easily what's called interactive queries. So as I mentioned, the nice advantage of this is it pushes the data to me. So I can subscribe to this topic and I will be notified whenever there's a change in the data. But maybe sometimes I'm actually interested, to go into it actually and get the current state. So I'd like to do what's called like a pull-based query. So let's say for a given weather station, I would like to see what is the current status of this data. And I can also do this using Kafka Streams. So all this data essentially is stored in a state store. And if I expose this, let's say via REST API, I can quite easily implement this kind of interactive query functionality. So let me just show you this one there. So I have this weather station endpoint, and this is now using the JAX REST API. Could equally well use Vertex. Maybe I should even have used Vertex here. It would have been maybe a bit more efficient even. But really then, this is quite easy because, well, I'm just going to this interactive queries object here. This is something actually I have defined. So let's take a look into that one to see what's happening there. And, well, all I need to do is I need to go to my weather station state store and essentially get the data out of it and convert it into JSON. And then a client, it wouldn't have to subscribe to this topic and then wait until the next change for weather station 1, 2, 3 comes in. Okay. But it could use this REST API and just ask, hey, what's the current data for this weather station with this ID?
So the weather station store is what exactly? It's like a key value store in Kafka or something like
Exactly right. So there's a RocksDB state store
that?
which underpins Kafka Streams. So also like all the intermediary state of the stream processing pipeline, all this is stored in Kafka Streams in RocksDB. And using those interactive queries, you essentially can do key-based lookups in the state store and get data out of it. And now what's interesting is there's a very, I would say, interesting deployment model behind this, because you can scale out your applications horizontally. So let's say, I would have like hundreds of thousands of weather stations, and I couldn't process all the data on a single machine. So the idea there is to scale it out, and in Kafka, the general idea to share your load is to have different instances of your application work on different partitions of your Kafka topic. So what I can do here, and I won't do it now because my machine is a bit broken, but what I could do is I run this like 3 times, like 3 instances, and then each of those 3 instances, they would essentially work on 1/3 of the topics of those of the partitions of this input topic. And now the problem, of course, is if I would like to have the current data for weather station 1, 2, 3, I need to know which one of those 3 nodes is actually the master of this particular data.
Yeah,
and
exactly.
Again, Kafka Streams makes it quite easy for me. So there's this metadata API for me where it tells me essentially, on which node a given key is owned. And then I could do 2 things. So I could either, in my REST reply, I could say, okay, this node, it doesn't have this data. It's located on this other node, so please go over there. And I could maybe use like a redirect. Or I could even, do this lookup myself. So I could use the REST client, like the microprofile REST client, and go myself over to this other node, get the data from there, and then answer it back to the caller. So that's I would say a pretty elegant way for scaling out your workload and just make this parallelized essentially.
And that can change dynamically, right? I mean, like let's say you have like you start off with like 100 weather stations and you're scaling to like 1,000, right? You can like on demand like repartition or whatever.
Exactly. Yeah, right. You could add more instances to the to this cluster. Essentially, those application nodes, they form like a cluster, so you could scale this up. And also, this nicely aligns with the notion of GraalVM, right? So this extension, it also allows you to run your Kafka Streams as GraalVM native binaries. And in this case, well, we don't care so much about the short startup time, so that's not so interesting here. But we do care about the low memory usage. So we could scale this out to many nodes, and then, well, it's very desirable, of course, if they use just a small amount of memory. So that's also something I can do.
Nice.
Yeah. So, and I mean, going forward, there's a few more things I would hope we can add to the extension. So let's say, like we have metrics here. So like we have health checks here, and really I need just to add another extension, and then the way it works is if Quarkus detects, okay, there's the Kafka Streams extension, and there's the health check extension, so then it exposes this health check for my Kafka Streams pipeline. And the same could be done for metrics. So Kafka Streams exposes a huge array of metrics via JMX. Now, one problem is if I run this as a native binary, well, then I cannot use JMX. It's just not supported by GraalVM. But then if I expose my metrics via HTTP to something like Prometheus, then, well, I would have those metrics. And I hope we will have this very soon. So it's a small amount of code you would have to do manually right now. But then we could expose all the metrics of the stream processing pipeline, like the number of events, like the lag, how much do you lag behind the source of data and all those kind of things, the rate of events. And this could be exposed to Prometheus, Grafana, and this would again be a very nice means for running this in production.
Cool. So do you have like something that you wanted to show us, like from a metric standpoint, like what this would actually what this looks like today, and like where you want to take it?
Right. Let me just check out this crunch. Okay, check out metrics. There you go. And essentially, I can show you glue code which I need for that.
Mm-hmm.
And you will see it's not too much, but that's something I need currently. I would have to write it myself, and essentially what it's just doing is, it's just looping over all the metrics which Kafka Streams exposes. So there's an API where you can get hold of all the metrics. Then essentially, based on the names, that they have very regular names and they end like with count or total and things like that, then I expose different kinds of metrics, either like a counter or a gauge, or maybe there's other things. But really, that's 100 lines or something like that. Here in this case, I'm using the micro profile metrics API. I could also use micrometer, of course, going forward. Mm-hmm. And then how it would look like is, still have this luckily here. It would expose me this metrics endpoint here, and this is something which then I can use as a data source in Prometheus. So that's like the Prometheus data format.
Yeah, exactly. Okay, that's cool.
And from there, I can take a very. Oh, I'm not looking into Grafana, but I could quite in a minute or so, I would have a dashboard, and I could see what's the history of my arrival rate and those kind of things.
That's cool.
Or maybe if somebody from the community even would like to contribute, that would be a great contribution. So I feel, it's not too complex to do, so you can quite easily get started with it. And it definitely would be a great addition to this Kafka Stream store in Quarkus to have also those metrics out of the box. And then you wouldn't have to do this manual glue code stuff. You would just add the metrics extension or the micrometer extension, and it would then expose this automatically for you.
Now that you mention it, do we have an open issue for that?
I'm not sure. I will check after the session, and then if there isn't, then I will create it and capture that one.
Yeah, that'd be nice. Like, because you brought this up, and so people probably hearing you might want to start contributing. So yeah, it'd be nice to get people
absolutely
to look at this. So cool. Yeah, that sounds like a very interesting thing to do for someone to get into Quarkus and that appreciates Kafka Streams.
Excellent. Yeah, and there's many other things you could do, right? So there's different, let's say, libraries which create like a visualization of your stream processing pipeline. So if it's a bit more complex than my case, it can be a bit hard to grok from the code what's the flow, and there's like different joins and mappings and whatnot going on. And there's tools which allow you to visualize this. So this would be another nice thing. Add another extension or maybe some option, and then you would have an endpoint there which exposes this graphical representation of the data flow.
Oh yeah,
so there's
awesome.
Quite a few things we could actually do. You just need more time.
Yeah, we always need more time. I know there's so much cool stuff to do, and
exactly right.
so little time to do it.
Right.
That's great. So how do you see like the adoption of Kafka Streams in general? Like, let's put Quarkus aside. Is Kafka Streams like really catching on in the market?
I would say absolutely, yeah. In Kafka land, this is super popular. People use this definitely a lot to do this kind of stream processing. People use it together with Debezium, the change data capture tool I'm working on. So one nice use case there is you could produce joins from different tables in your data, right? So by default, Debezium produces one topic per table. And oftentimes people would like to have like a joint view of this data. Let's say they have order lines and purchase orders. So it's like a 1-to-n kind of relationship. Well, you could use Kafka Streams and join those two topics together. And there's support for this is getting better and better. And then you would have this kind of enriched data structure. So yes, absolutely, people use this a lot in Kafka.
Cool.
Yeah.
And I assume like in that sort of case that you would. It's fairly easy from Kafka Streams to pull out the data and then like write it back to the database or something, right?
Yes, right. I mean, if you wanted to do that, so what you could do then is, have Kafka Connect, sorry, which is this environment for connectors like Debezium and Kafka Streams together. So and then what you can do is you have like source connectors. They get data out of a data source like a database, put them into Kafka. Then you would do your stream processing using Kafka Streams. And then you would again use Kafka Connect and then what's called a sync connector. So this would take the data and, for instance, write it to Elasticsearch. So coming back to this example with the purchase orders, let's say you would like to have a full text search on your data. Then you would like to have this data of purchase orders in a single index in Elasticsearch. So, which is like a nested structure of one purchase order, and all the order lines, they're like embedded into a single document for each purchase order. So this is something you could quite easily do by combining Kafka Connect and Debezium on the source side, then Kafka Streams on the enrichment side, and then maybe things like the Apache Camel connectors, which come with support for Elasticsearch and all kinds of other data stores on the sync side to write back this data.
And all that stuff, of course, could be written in Quarkus, right?
Yes, I mean, yes, you could do the stream processing in Quarkus. The nice thing about Kafka Connect is you don't need to implement anything, right? This is more, you just use those ready-made connectors and you configure them. So you point them to your database and you configure the credentials and maybe some, easy transformations, those kinds of things. But it's all configuration-based, so you don't need to do any bespoke coding. So this really would be limited or focused on the stream processing side, and there you would use Quarkus. Absolutely.
Gotcha. Right. One other thing I never really understood, or I never really actually looked into. How does KSQL fit into the Kafka Streams picture?
Oh yeah, so KSQL, it's a layer essentially on top of Kafka Streams, and this is more like a declarative way for expressing the same kinds of logic. So, it's already in the name, so it's inspired by SQL. So instead of doing this Java API way of, doing joins and grouping and so on, there it would be like a SQL-ish way to express yourself. And I guess it widens the audience who can work with that. So you don't necessarily need to be a Java programmer to use that.
Okay, but do you still need like a deployable somewhere? Like where does?
Yes, to be honest, I'm not super sure. I think it's a dedicated runtime, so it would be like its own service which runs somewhere, and it takes then this KSQL definition and executes it essentially. Okay,
so yeah, but from a Java developer's point of view, it doesn't make tremendous. It sounds like it doesn't make a tremendous amount of sense to do that.
Yeah, I guess it's a matter of preference and what you would like to do. So I definitely feel more at home with this Java-based approach, but I also can see how something more declarative might be more appealing to some folks.
Gotcha. We have a question here.
Yeah.
It says, I would like to know if the communication with Kafka is being done using non-blocking I/O.
I would say so, yes. I mean, this is all asynchronous, right? And it's using the regular Kafka producers and consumers under the hood. So yes, that's all async and non-blocking as such. Yeah. John says, yeah, it's both Kafka Streams and also reactive messaging. It's all async. So.
Yes, yeah, that's what I was going to say. Like in the demo you did the previous time around when you were using just the Kafka. Not Kafka Streams, with the regular Kafka integration. That's all with reactive messaging. So as is in the name, it's non-blocking, right? It's
exactly right. Messaging. So actually, we can also take a look at that one. So we do have 1 full hour. Is that right? Because I thought we had 30 minutes. So we got 15 more minutes essentially, right?
Yes, yes.
Okay. We do. All right. Okay. So then, yeah.
You have plenty of time to.
Okay. Cool. Sorry, I thought you would have like 30 minutes.
No. It's 1 hour.
All right. Yeah, so that's this source of measurement, right? And here, this is using this reactive messaging API, which is super easy to use for this kind of use case, right? So again, you just have like an application scope CDI bean, and then you define those outgoing, in this case, outgoing flowables. So they are essentially data producers, right? And what happens here is every 500 milliseconds, every half a second, this will produce like a new temperature measurement and sends it to this channel here. So that's like a logical channel temperature values. The same is here for my weather stations. In that case, it's just like a fixed set of, a fixed amount of data from a given iterable. So, once it has produced those 9 elements, then it's done. Here, this happens every half a second. And it writes it to those logical channels, temperature values, and weather stations. And you can take a look into the configuration of that one. And this is how it's wired, right? So here, essentially, I'm saying, okay, this outgoing, it could also be incoming if I were to consume a topic, but here in this case, I'm just producing data, so it's all outgoing. And in that case, it says, okay, this should be this logical channel temperature values. It should use the Kafka connector, so there could be different connectors, and it still gives me one unified API on top of that. And it uses those serializers. So in Kafka, you need to know everything you send to Kafka is just binary data. It's like a blob of data, really. This means this semantic structure, be JSON or a string or whatever you use in our application, needs to be serialized. And this is where those serializers come into play.
Right.
But really,
so basically, with like six properties and like 2 annotations, you've implemented a producer, right?
Exactly right. And it would be, even simpler for consumer. I would just have an incoming annotation here. It would be tied to the name of the topic or my logical channel. And then I could react to any message on this topic there. So that's quite nice. And I think those things, they complement each other quite nicely, right? So here, this makes it super easy for me to just write data to a topic, consume data from a topic, things like that. Then if I go into this notion of stateful stream processing, I need to do things like joining and windowed operations and groupings and aggregations, and I need the state store underneath. Well, then I can use Kafka Streams. And those things can quite easily be used together with Quarkus.
Great, yeah, that really sounds like they really like complement each other. So you would need like you need. I'm imagining like in any real application, you would need like both things, right?
I would say so, right? I mean, definitely. If you had like you just want to consume messages from a Kafka topic, maybe it's like a microservices architecture. You get data from another system. Well, then you would use, you wouldn't have to do any processing really in terms of Kafka Streams. So you just would use this reactive messaging API, would implement your consumers, you would get the data and call it a day. And yeah, then if you have this kind of, really complex stream processing logic, then you would use Kafka Streams and you could choose which to use based on your use case and requirement each time.
Right. But a lot of the times, like you start out like, okay, then I just want to get something done, and then but someone else comes around and he says, oh yeah, I want some data, some analytics or something on like what the purchase orders are or whatever, like the example you mentioned earlier. So when you start out with something like with Kafka, then you can automatically use Kafka Streams with Quarkus and get real good like analytic answers really fast, right?
Absolutely right. And the really cool thing is it's all push-based, right? So let's say you have like a chart, I know, with some data in your browser and you would like this to be updated via WebSockets or server-side events. Well, you could underpin this using Kafka Streams. Then it would update your browser view, like in near real time. Whenever there's a data change, it would update your view. Or let's say you have like a thing like a back office client. Maybe you would like to have an alert if your inventory goes below some certain threshold. Somebody needs to look into that. So that's something you could quite easily implement using Kafka Streams. And that way you would add something like WebSockets or maybe GraphQL subscriptions to push it actually to the browser. But it doesn't require too much code to do so.
And in Quarkus, you already have WebSockets and GraphQL support.
Exactly right.
Well, that would just make it really easy. Actually, we have a question based on what we were just discussing.
Yeah.
Kevin's asking how to choose between Kafka Streams and MP reactive messaging. Are they complementary?
Yeah, definitely, right? So absolutely, as you mentioned. So I think they're complementary. So if I have a use case where just need to produce data as in my data source here, or where I just need to consume data, I would use the reactive messaging API. If I were to do this kind of stateful stream processing where I need to join data, have windowed operations, groupings, all these kind of things, then I would use Kafka Streams. And we can combine them, right? So here I have my measurements. They are produced via reactive messaging, and then they are processed using Kafka Streams, another microservice. So you can use them together.
Excellent. Excellent. Okay, so I think we have another question. Oh, wow, I made a mistake here. The caption was hiding us. Okay, so we have another question that says, what transformation would need to be applied, if any, to materialize Debezium's change data capture from a MongoDB source, for instance?
Oh, wow, that's an interesting one. From a MongoDB source. Okay. Yeah, so let's say the challenge with MongoDB is it doesn't have a fixed schema, right? So for each element in your collection, they could have, in theory at least, like a different structure. I mean, typically you wouldn't do this. I mean, if you have like a collection of purchase orders, they will kind of have the same set of fields, but there could be, like new fields being added, and you have like a kind of irregular structure. Whereas with the other Debezium connectors, all the relational ones, they have a schema which strictly resembles the table which those events are captured from. So that's why in case of MongoDB, the change events, they essentially are like a patch string. So it's essentially just like a single field, which is in MongoDB format, which describes which fields have been affected by a given update, for instance. And then it's, by default, it's up to the consumer to interpret that string and make sense out of that. So what we produce, or what we have in Debezium, we have what's called a single message transformation. So let me see if I find that. Debezium documentation, opening, let's go there. And those single message transformations, SMT, they take any Kafka Connect record and can modify it, either before the data is even sent into Kafka in the first place, or when a sync connector consumes the data. And what we have for MongoDB, it's a bit of a mouthful, the MongoDB new document state extraction SMT. And what this one does, it takes this patch string, which we get from the MongoDB connector, and it produces a typed structure. So this is how it looks like. It's a simplified example. But what you would get by this connector by default is, this single string, which contains like a JSONified structure of my fields in my MongoDB document. And if I apply this SMT, I would get a typed structure which contains the fields in a structured fashion.
Right.
And now I would send this to Kafka. So, and it's all described here how I need to apply this. So I say I would like this transformation. There's quite a few of options to configure it. But then if I do all that, my Kafka topic would contain those fields in a typed fashion. Still, the fields which are present or they're typed, they could change between messages. But I could now, for instance, use, let's say, the Elasticsearch sync connector and quite easily sync this data into a search index. Or I could also use it with a relational database, but I just need to consider what is implied by a given schema change. So let's say I have this field 1, and it changes its type between documents. In one document, it's an integer. The next document, it's a string or date. If I would like to write this data to a relational database, probably will be quite challenging because I would have to update the type definition of this column, right? But on the other hand, usually you wouldn't probably do this, so then you would just be fine.
Okay, so cool.
I hope this answers the question, but definitely check out this SMT. This, I think, will be helpful for you.
Nice. We have another one that says, would you use KStream for just a simple message transformation?
Yeah. So now that's time for the marketing department. Because I wrote a blog post. So let me go and find that. The thing is, So I'm assuming you ask about Kafka Connect and maybe something like Debezium. And if I can get away with implementing an SMT, such as single message transformation, I would definitely do so. So let me just find the blog post there. There you go, single message transformations. So this discusses this very point, actually. I hope people can, find it there. I'm not sure whether you can put it to the chat or something.
Yeah, I'll put it in the chat.
Yeah.
Put it in the chat.
So, and this discusses this matter a bit. What can you do with an SMT in Kafka Connect, and when is it not enough? And you will look into Kafka Streams. And the thing is, so if I would get away with implementing such an SMT, I would do it because it means it's very easy for me to operate. I have Kafka Connect running anyways, and just deploying another SMT to it, this really doesn't add any operational overhead to me. Whereas if I deploy another Kafka Streams application, well, then that's another microservice. I need to monitor it. I need to, just operate it, right? I need to keep care it's running. I need to keep it up to date and all those kind of things. So if I really have this kind of requirement that I need to do this kind of joining and whatever, if I just want to modify, let's say, the types of my properties of individual messages, then such an SMT is ideal for that, and I would just use that. But sure, if I need to go beyond that, if I need to process multiple topics and correlate them and group them and whatnot, then I would reach out and use such a Kafka Streams application.
Yeah, I think that's a really practical approach. I mean, start with something that makes sense to get started easy, and then when you actually do need something more complex, move to it.
Exactly right.
We have one more.
Sure.
It says, it's a large one. It says, talking about microservice architectures and sagas, is there a way to maintain and read, the current state? You can't see the whole thing on the screen, so I'll just have to read it.
Okay. That was one. Now the exciting part. That's missing. Keep going.
So yeah, this is, I guess, a bug for Restream that we'll have to file or something. And it says, okay, I'll take it from the beginning. Talking about microservice architecture and sagas, is there a way to maintain and read the current state of the saga using K-Streams K-Table, which comprises of multiple microservice actions?
Wow.
Yeah, that's a mouthful.
I mean, so I'm not exactly sure how sagas fit into this picture, to be honest. But if it comes to those read or pull-based queries, definitely check out interactive queries, as I was mentioning them, right? So just to give this example here with the weather stations again. So, come on. Where you go to the state store and get the data for a given entity by its ID, right? So I believe this would help in that context. As I said, I'm not totally sure how sagas fit into this. But really, if you have a stateful stream processing application, Kafka Streams, and you would like to get the current state out of it, definitely check out the interactive queries, which are exactly meant for that.
Great. That's good stuff. So yeah, I think we have a lot of interest in Kafka in general, because I'm sure people have seen a lot of big shops are using it.
Absolutely, yeah, it's huge. I mean, so with Debezium, I'm part of the Kafka ecosystem, but it's so widely used and people are just in love with it. It's the hot thing, for sure.
I have one not Quarkus related. I heard some stuff, but I haven't had time to look into it. So what's going on with Kafka and they're trying to drop Zookeeper?
Oh yeah, right. Yeah, so the thing is, you need Zookeeper essentially for managing state of the cluster and, finding majorities, things like that, managing metadata. And, now I'm not operating Kafka myself in production, but what I hear is it adds a lot of overhead and it's just complex to run. So people have a desire to get rid of Zookeeper. I mean, I think it does what it needs to do, like consensus forming and so on. It does it well, but it's a pain to operate. So that's what I understand. And so that's why Kafka is, the Kafka community is working towards getting rid of it. And essentially they implement their own raft-based consensus algorithm. So then, the Kafka brokers themselves I think there will be different roles of Kafka Progress, so this is handled within the Kafka cluster itself. So you don't need to have this separate component to operate, which is Zookeeper. I mean, you even see it in my little compose file, right? So there I had Zookeeper and Kafka.
Exactly.
Well, it would of course be nicer if I just need to have solely Kafka, right?
But from like a Java consumer's perspective, would like the libraries need to change, because now you do configure like the Bootstrap or something like that, right?
Yeah, no, for Java consumer or client, this is all transparent, so it doesn't interact with Zookeeper at all. So really, this Bootstrap URL, which we have seen somewhere here, that's the Kafka, not here, somewhere. That's the Kafka Bootstrap, one broker of the Kafka cluster. So if Zookeeper were to go away, it shouldn't impact Java consumers, really.
Okay, cool. So it's all about making it easier for the folks that actually run Kafka.
Exactly right.
The
so
DevOps folks that run Kafka
exactly.
production.
So at least that's my understanding. This is like 99% an operational matter, and how you run this and make it easier to run this in production.
Excellent. I mean, this.
But,
cool. Yeah, go ahead.
Yeah, no, I just want to say I think there's still quite some time out into the future until this happens. So that's happening tomorrow.
Cool.
Yeah.
So we're at the top of the hour. I think we had a great discussion here. A lot of insight from Gunnar, and really touched on a lot of topics here. Great questions that
absolutely, that's really cool
from our folks watching. So thanks a lot, everybody. Thanks, Gunnar, for being here a second time.
My pleasure.
Hopefully, we'll have you again a third time.
Yeah, we can talk about serverless.
Excellent.
And I mean, if people, still have questions, feel free to reach out to me online or on Twitter or wherever you find me, and I will be very happy to answer your questions as I can.
Great. Thank you, Gunnar. So just a quick reminder for folks, there's another Quarkus Insight session in, I think it's 2.5 hours about how to contribute to Quarkus. And that will be done by one of our premier community contributors. So we'll be showing some insights to that. So if you want to be here around 2.5 hours to see that, that'll be great to see you again. Otherwise, we'll catch you all in a week or so for the next one on Monday. So
maybe we will find a contributor for the metrics integration.
Yeah, that'd be great. That'd be awesome. I mean, it's super useful, and from what you showed, it shouldn't be too much work.
Shouldn't be too much, exactly right. Yeah, would be a nice way to getting started with contributing to Quarkus.
Excellent. Cool. So thank you very much, everybody, and I'll see you around.
Bye-bye.